we'll look at questions where we need to find the points, um, of where a curve has a specific tangent. Now this is taking a bit of a step further, and it's asking us to find the equations of the tangents, right? So the actual equation of the line that cuts the curve. So, for example, if this is our graph, and we want to find the tangent of the gradient, we want to find the whole equation of this line, of this whole tangent, and that's basically what we're doing in these trim questions here. So I'm just gonna label this as A and B, and let's get cracking and try these questions out. So this first one, we've got the equation y is equal to x squared plus x plus 4. And they've given us 2 points. A is 1 over 3, at 1 at 3, and B is negative 1 and 1. So obviously, as you already know, with equations like these, at different points, you're going to have different gradients, right? And therefore, you're going to have different tangents, and therefore, we're going to have different equations. So we want to find the equation of the tangent A at point A and at point B. So we're going to look at both of them. Okay, so it's a two-part question. So first thing we're going to do is we're going to derive the equation, right? So since we're given y here, we're going to use the notation dy over dx. And again, deriving this is just 2x. X just becomes 1, and the constant 4. You just get rid of that. Okay. Now, we want the to find the derivative, we want we want to find the slope, or we want to find the gradient where x is equal to 1, right? We want to find what the gradient is going to be when x is equal to 1. So if we just sub in x is equal to 1, dy over dx, we'll just write at x is equal to 1, the gradient is equal to 2 times 1 plus 1, okay? Which is equal to 3, obviously. Okay, so now what we have is we have our x coordinates. Do we know our m is equal to 3? Well, we're not just finding the gradient, we need to find the whole equation. So if you remember from linear equations, we have a point slope formula, which basically states that y minus y1 is equal to m, and then x minus x1. Right? So we can use that to find the equation of this tangent. So our y1 is our y coordinate, which in this case is 3. Our gradient is also 3 from what we just found, and our x coordinate is 1. Therefore, we know that y minus 3 is equal to 3x minus 3. And if you bring the 3 to the other side, y is just equal to 3x. So the equation of the actual tangent that passes through this equation at this point, the equation of that tangent is y is equal to 3x. Okay, so in so y is equal to x squared plus x plus 4. The tangent, so pretend this is the equation of y is equal to x squared plus 4. The equation of this tangent is going to be the y is, assuming that this point is 1 and 3, where it cuts the cut. Okay, now we'll do the same thing for the second point. So again, we already have our derivative as 2x plus 1. And now we want to sub it in for x equal to negative 1. So we know that at x is equal to negative 1, dy over dx is equal to 2 times negative 1 plus 1, which is equal to negative 1. So that's our m now. Okay? So again, using the point gradient formula, we've got y minus y1 is equal to m x minus x1. And then we've got y minus our y coordinate, which is 1, is equal to negative 1, which is our gradient. And then our x coordinate is negative 1. So x minus minus 1 becomes x plus 1. Okay, and then solving for that, y minus 1 is equal to negative x, negative 1. Bring the negative 1 to the other side, and then y is just equal to our negative x. So when we're at negative 1 and 1, then this is the equation of the tangent. Okay? What I can also do for you guys is I can make a video of a graphical representation of this as well. So, it might help you guys understand this concept a bit more. But what you guys can also try and do is just go into an online graphing tool, go into Decimos, or any other online graphing tool if you want to graph it yourself, and just draw up these graphs, and you'll see what I mean. You'll see how the tangents actually connect and how they're different at each of these points. Okay. Okay, and then the second point, second question, it's asking us to find the coordinates of any points where the tangent to the curve is horizontal. So we're not finding the equation for this one, we're just finding the coordinates. So make sure you guys listen to the wording as well. I'll put that specifically here so you guys will know, just to be careful about the wording in these sort of questions. Especially if you get an exam, if it asks you to find the equation and you've only found the coordinates, you're not going to get the full marks for that. So let's do part B over here. So we've got fx. Notice how we've got different notation here as well. We had y for the first question, and now we're back to fx for part B. So those are just some subtle variations that you're going to get in these sort of questions. Is equal to x4 plus 16x squared. So again, we've done questions like this before. We need to just find the coordinates of any points where the tangent to the curve is horizontal. Remember, tangent to the curve is horizontal, just meaning that the derivative is equal to 0. Okay, that's what we're looking for. So let's find the derivative of this curve first. So f dash of x is equal to 4x to the power of 3 plus 32x. Okay, that's our derivative. And because we want to find the point where the tangent is horizontal, we will set this equal to 0. So if f dash of x is equal to 0, we'll set 4x to the power of 3 plus 32x equal to 0. Now let's factorize this. We can take out 4x as common. Then we have x squared plus 8 is equal to 0. Now that means to solve this, either 4x is equal to 0 or x squared plus 8 is equal to 0. Now 4x is equal to 0, that means x is equal to 0. And this one has no real solution because x squared cannot never equal negative 8. So therefore, no solution for that one. And that means that at this point, there's only one point where our tangent is horizontal, and that's at x is equal to 0. If this was, say, for example, a negative, then we could have multiple points where the tangent was horizontal, but it's not. So if we just use this, and then we sub that into our equation again, remember, because we need to find the coordinates and not just the x value. So that's equal to 0 to the power of 4 plus 0 plus 0 squared, which is also equal to 0. So that means that the only point on this graph where the tangent is horizontal is at the origin at 0, 0. Okay, so two different types of questions here, both of which you will get in an exam, both of which are, multi-part or a bit harder questions, more application based. I would highly recommend you guys to go on Decimals, so graph these yourself and get a better understanding of how these curves and how these tangents work.